As promised, I have not read this question before this starting this video. So let us all learn what is the question, understand it, and then we will look at what we are required to tell. So this is actually an exam question. The question is not too big, and it looks like it is a design question, design problem. A design problem is one where we have to come up with uh, finding the values of the components of a circuit. So for example, we may be required to come up with the value of RF, R3, R2, and R1. Maybe. Let us see what the question says. In a certain building, it is required to know the status of two doors, A and B. So there is a door A and there is a door B, and we want to know the status of the doors. Now, what status can a door hold? Obviously, whether it's open or closed, whether they are open or closed. A student of engineering decided to make a circuit and use a special light to indicate the state of each door. The light glows with different colors based on the voltage VL applied across it, as per this following table. So if VL is less than 2 volts, so if there are 2 volts, less than 2 volts across the light, it remains off. So it means that both the doors are open. So if there are less than 2 volts across this, then the light is off, and it means both the doors are open. If the voltage is between 2 volts and 4 volts, the light glows with a green color, and it means that door A is closed but door B is open. If it is between 4 and 6 volts, then it means that it will glow with a red color, and it means door B is closed but A is open. And if it has a greater than 6 volts across it, it glows with a yellow color, and both are closed. So when both are open, actually, like suppose these are the door switches, you can connect switches in the doors. So if the door opens, the switch opens. So let us say the status of the switch is actually the status of the door. So if this switch opens, we say door is open, and if the switch opens, we say the door B is open. He came up with the following circuit for the task. The two switches labeled A and B represent the door A and B respectively. If the switch is open, that is circuit broken, it means the door is open. And if it is closed, means the door is closed. Find the values of the voltages V1 and V2 and the values of the four resistors such that the desired voltage is obtained across the light to show the correct status. Now, when everything is left to us, we are free to make any choice, obvious, but we are obviously limited by these characteristics or this data. So whatever voltages we choose here, so suppose we have a battery of 9 volt available with us, or maybe 5 volt, or maybe 10 volt, or 12 volt. It does not matter what actually is the value, but we have to choose something. Let us, for the purpose of this question, let us assume that V1 and okay, before we actually assign some values to these two, let us try to find what will be the output voltage VO here. uh, uh, how would VO depend on V1 and V2? If we can come up with an expression, which we obviously can. So just looking at this circuit, we know that whatever voltage we apply here, no current is going to flow in here, and we are going to get this V1 here, and this must be V1. So whatever is V2, this will be V1. So if we apply NVA here, NVA equation here, we can write V1 minus VO over RF. Let us assume this is closed, or if it is closed or not, we are going to see that the equation will change based on which one is closed and which one is open. V1 minus V2 over R3 plus V1 minus V2 over R2 equal to 0. So this term may or may not be there, and this term may or may not be there. Let us say um, this term is the A term representing the door A, and this is the V term, and this will always be there, and this will always be V1. It does not matter what's happening here. So if both are open, we will still be having V1 here. If they are closed, we are still going to get V1 here. Okay. So if these are open, nothing is flowing in here, we get V1 here, and if both are open, we need to have VL less than 2. Then no current would be flowing here, so no current can flow here, and this V1 will appear here. So if both are open, for both open case, VO will be equal to V1, and we know that for this case VL must be less than 2 volts. So this tells us that V1 cannot be greater than 2 volts. So let us say we choose V1 to be equal to 1 volt. In that case, if both are open, we are going to get VO equal to 1 volt, and the light will be off, which means both are open. Now the question is, we want to okay, let us now consider the other case. Now door A is closed, so this case is handled. Door A is closed, so this is closed. Now the equation is V1 minus VO. V1 is now chosen to be 1 volt. 1 minus VO over RF. So with this value of V1 of 1 volt, when both are open, it does not matter what are the values of the resistors. So any value of resistance will be okay, and this will remain closed off. But let us come to this equation now. 1 minus VO over RF plus 1, and this is closed. Door A is closed. 1 minus V2 over R3 equal to 0. Now we know that VO for this configuration must be between 2 and 4. So we can see that in order to get VO, RF multiplied by 1 over RF plus 1 over R3 minus V2 over R3, or VO is equal to 1 plus RF over R3 minus RF over R3 into V2. So VO is going to be equal to, now we know V2 shouldn't be greater than 4 volts. So let us put 4 here and see what do we come up with. 4 is equal to 1 plus RF over R3 can be taken common from here, 1 minus V2. So this says that R is equal to RF, 3 is equal to RF over R3, 1 minus V2. So in this equation, we have to choose V2, so that, and the value of RF and R3, so that VO is 4 volts. So let us say V2 is equal to 2 volts. Obviously, we cannot choose V2 equal to 1 volt, because 1 minus 1 is going to be 0. And in choosing, in having 0 here, we cannot get it equal to 3. And we see that this is a positive value. RF would be a positive value, R3 would be a positive value. 1 minus V2, this the term in the bracket must be a positive value, because a positive value multiplied by a positive value will result in a positive value. So V2 cannot be 1 or less than 1, or greater than 1, because it will become negative. So let us say V2 is, say, 0. So in that case, if this is 0, we are going to get RF over R3 equal to 3. When such a equation comes where we have only one equation and two unknowns, we assume one term. So let us say let R3 is equal to 1 kilo ohm. Then RF will be 3 kilo ohm. But remember, we started with this to be 4, but this 4 is the max value that can be had. So we can see that this 4 must be greater than these things. I mean the next side. So this states that RF over R3 must be less than 3. So this cannot be 3 kilo ohm. RF should be less than 3 kilo ohm. So suppose we come up with RF is equal to 2 kilo ohm. Let us see if that fits in here. So if V2 is 0, this term gets out to be 0, then 2 over 1 would be 2 plus 1, 3. VO would be 3, and 3 means door A closed. It serves this. So let us come to door B closed now. We are going to have exactly a similar situation here. So obviously we are going to have an equation exactly like this for this third case. Okay, if V2 is 0, which obviously cannot change because we have considered it to be 0 for one case, it must be 0 for the other case as well, then RF over R2 would be less than, now here it is 6, it was 4 minus 1, so it is 6 minus 1 here, that would be 5. So we cannot change RF now. RF is 2 kilo ohm, would give us the value of R2. So 2 kilo ohm must be less than 5 into R2, or R2 must be greater than 2 over 5 kilo ohm. Let us say R2 is equal to 2 over 5 kilo ohm, which is 0.4 kilo ohm. So with 0.4 kilo ohm as R2, we are going to get RF2 over 0.4, 2 over 0.4, 20 over 4, which is 5. So 1 plus 5, we are going to get 6. It must be greater than this, and greater than this means, let us say it is equal to 0.5 kilo ohm. So we can see that 2 over 0.5 will be 4, 4 plus 1 is 5 volts. So 5 volt is going to show that door B is closed. So when both close, now we have almost found the value of every resistor. and the voltages as well. But let us see the fourth case also works as well. We have not found the value of this one, but let us say it is 1 kilo ohm because nothing probably depends on this. And RF has been chosen to be of a value of 2 kilo ohm. R3 has been set at 1 kilo ohm. R2 found to be or set at or chosen to be 0.5 kilo ohm. So let us take the fourth case. Let us see whether this gets satisfied or not, and whether VO is equal to whether VO is satisfied in this equation. So in this equation, we can see if VO over RF goes to this side, we can eliminate it on this side. So let us see if we can satisfy this. V1 is 1 over RF, which is 2 kilo ohm, plus 1 minus 0 over R3, which is 1 kilo ohm, plus 1 minus V2, which is 0 over 0.5, is equal to VO over RF, and RF is 2 kilo ohm. So we get 1 by 2, 0.5 plus 1 plus 2 is equal to V naught over 2. We get 3.5 into 2, that is 7. VO equal to 7. So you can see the fourth case is also fulfilled. I remember this question to be a bonus question in a final exam, because I might have covered similar questions in the course as well, and this would just be a different wording or different problem for the same kind of circuit. So while this may look like quite challenging to you, it's actually not, and we'll come to such design problems later in further courses actually, because this is a course of analysis. But even then, I hope you will learn a lot in knowing how design works, how requirements are given to us, and how we come up with something. Now you see, we have exactly a circuit designed. We have a 2-volt source connected here. We have this grounded because we want to apply 0 volt here. If we have this 1 kilo ohm, 0.5 kilo ohm, 1 kilo ohm, 2 kilo ohm resistors, and such a light with this configuration and these two door switches, we obviously based on this table can find the status of the two doors.